We learned in elementary school that there are 3 states of matter: solid, liquid, and gas. So what form of matter is a supercritical fluid? Let's ask the Deputy Chief Scientist at the Bluegrass Chemical Agent Destruction Pilot Plant, George Lucier.
I think the best way to explain a supercritical fluid is to think about when you're cooking in the kitchen and you're boiling water on the stovetop. You have to put a certain amount of energy into that water to bring it to a boil. If you're living in Denver, that water boils at a lower temperature than if you're living in, say, New York, where you're at sea level. So the altitude has an effect, and that's because of the atmospheric pressure. Now, if we take that to an extreme where we put lots and lots of pressure on that solution, we have to take it to a really high temperature to boil it. At that point, if we're beyond what's called the critical point of water, the water doesn't actually even boil. So once you get past the critical point of water, that is when you're high enough in temperature and high enough in pressure, then you no longer have something that behaves either like a gas or a liquid. It's somewhere in between.
At BGCAP, the chemical agent will be destroyed using a 2-step process: neutralization followed by supercritical water oxidation, or SQO. But what exactly is SQO?
Supercritical water oxidation is used here at BGCAP to basically break down the hydrolysate, which we get from the main plant, and break it down into salts and water and a few gases.
Hydrolysate, a byproduct of neutralization, is broken down by SQO inside these 15-foot tall reactors. Hydrolysate, fuel, and water are added to the top of each SQO reactor. The reactor heats this blend under high pressure. Once it reaches supercritical conditions, the inorganic salt materials will settle out of the solution. When the supercritical fluid reaches the bottom of the reactor, cooled water is introduced to quench or cool down the solution.
Supercritical water oxidation provides a means by which we can take the hydrolysate that's generated in the main plant and convert it into a benign salt solution, very much like seawater.
Supercritical water oxidation will break down the agent and energetic hydrolysate into a salt solution that can be transported to an off-site permitted disposal facility.